My name is Lucas Magno. I am the lead electrical engineer for Gator Motorsports. When I got on campus my sophomore year, after doing online for the first year, I was looking for design teams to join, and I walked by the shop, toured the shop, and thought everything that we were doing was really cool and decided that I'd join. I really like that at Gator Motorsports we're very encouraged to push boundaries and try new things, put more work into design. If you have a new idea, a new way to do something, you will be more than welcome to try it, see if it works, design it, manufacture it, test it, all of that. It very much mirrors real industry, and that's the goal of the team, is to build better engineers. My favorite part about the team is that even though I'm the electrical lead, I can get involved and help with all of the other systems. I've manufactured parts for the cockpit system, for suspension, for chassis. I've been involved in design for other systems a little bit as well, and that's encouraged for everyone that joins the team. Focus on a system so that you get really good at that one system, but also feel free to move around, learn new things, and help the entire team grow. So, moving into EV, we take apart the entire car and get rid of about half of it. The entire powertrain, the cooling system, the oiling system, the intake, the exhaust, all of that goes away. You also have to then make significant design changes to your chassis and to your suspension. In the electrical system, a lot of the challenges that we have are with the large growth of the system. It went from largely off-the-shelf components and wiring to lots more off-the-shelf components and a lot of custom electronics, more difficult wiring to design and manufacture. And then some of the larger challenges on the scale of the team are packaging the large battery pack and integration with all of the other systems now that everything is new, and the rules compliance, because EV has much stricter rules than the internal combustion. In tackling the challenges with building an EV, we started early. We started last fall, and that really ramped up the previous spring. From there, we evaluated various designs and had several integration meetings on making sure that everything will fit, that the system will be a well put together engineered system and not a collection of parts that are bolted together. And for the electrical system, we just went for a nearly clean sheet design, redesigning almost everything. As an engineer in the team, I've acquired many skills that you wouldn't acquire in classes, and I've used a lot of the knowledge that I've gained through classes. Electronics designed, harnessing, wiring, reliability testing, high voltage experience, all of that I've acquired through the team. You also gain a lot of knowledge on electric vehicles and how they work, in automotive, in vehicle dynamics, in motor controls, and all of that is extremely useful knowledge to have going into industry and going into internships. The old electrical system doesn't work with the new hardware. So we could have bought new off-the-shelf hardware and integrated that into our system. Or we can design and manufacture and test and program everything ourselves, and that's what we chose to do. With that comes a lot of electrical design and also a lot of software development. So the software team has grown from non-existent to a team of 5 people that have collectively written about 50,000 lines of code.